Yeah, it's not that question. I think the question is 2294. Let me go back. Yeah, it is 2294. Yeah, so let's try to solve this question. Partition array such that maximum difference is k. So we are giving an array nums and we are also giving a k. So we may partition the nums into one or more subsequences such that each element in nums appears in exactly one of the subsequences. So this description is a little bit confusing. Actually, it means we can split the nums into 2 parts or 3 parts or any part. For example, 3, 1, 2 and 6, 5. Because a subsequence is not continuous, it means we just need to take some numbers from the nums. So for example, we take 3, 1, 2, 6, 5, and we split it into 2 subarrays. And we're going to return the minimum number of times. So such times is calculated by the maximum or number in this subarray. So it's going to be 3 and minus the minimum number. So it is 1, so it is 2. And for 6 and 5, the maximum minus the minimum is 1. So the result should always be less than or equal to k. K is 2. So we're going to count it as 1 time. So those 2 subarrays is possible. So it's going to be the minimum subarrays. So we're going to return a 2. Yeah, because we cannot find a 1. Because if it is 1, it is 1, 2, 3, 5, and 6. And 6 minus 1, it is 5. It is not 2. Yeah, if we were to split it the minimum number of times, so the result is going to be 2. But how can we solve the problem? We have to use some greedy ideas to solve the problem, because if we are giving an array like this, how can we split the array to make it to make the splitting of the array, to make the partition as small as possible? So the idea is that we can sort the array. So what about we just sort the array in increasing order? So after sorting, we're going to check how many splittings. So for example, we can find 1, 2, 3. It is 1 split, because 1, 2, 3, 3 minus 1, it is 2. And another split, 5 and 6. This is another split. But if we don't use the greedy idea, so what about we use 2 and 3? 2 and 3 is possible, so this is one solution. So what about the other one? Maybe 1 and 5 is not possible, but 5 and 6 is another splitting, so it is 2. But we still have a 1, so it's going to have 3 times, but the number going to be 3. It's not 2. It's not the optimized solution. So this is why we're going to use the greedy ideas to solve the problem. Basically, it's a simulation. So first of all, we're going to sort the nums, and then we're going to check one by one to check how many splittings. While we check the splittings, we can just use a sliding window or 2 pointers to solve the problem. Yeah. Now let's just start coding. So let me delete these areas. So I'm going to prepare a variable n. It's going to be the length of the nums. And I'm going to prepare a left pointer. It's going to be r. And also I need to prepare a result. It's going to be equal to, yeah, let me check. So the result would be equal to 0. It doesn't matter. Yeah, because with the result is just a counter. We just needed to return this result. Now I'm going to check the numbers one by one. So for r, we enumerate of the nums. So I'm going to check if this number v minus the first number at the L, the number at the L. So I'm going to check if v minus nums L, if it is more than k, definitely I'm going to have a counter. So the result would plus equal to 1, because I found one continuous sequence. So the array would be something like the first example, 1, 2, 3, 5, and 6. So it means from here, I've already found one result. Next, what am I going to do? I'm going to update the pointer. So L should equal to R, and I'm going to check the next. Here is 5, and here is 6. So the L, nums L is 5. And then I'm going to check 6. 6 minus 5, it is less than k. But as we can see that the result should be 2, not 1. But how can we make that? We can just prepare some boundary check. So the nums should update it to nums plus infinity. So this means For 5 and 6 it is okay, but for the next number it's gonna be infinity. Infinity minus 5 it's gonna always be bigger than this k, no matter how big is the k, because this k should be 10 to the power of 5, but this infinity definitely more than this number. So we just needed to change some nums and then make it right. Now let me run it. I think it should be wrong because I didn't sort the nums. Did I sort the nums? Yeah, because I didn't sort the nums. But for here, the nums has already been sorted, but actually the nums is not sorted. So this means we need to sort the nums. So I'm gonna put it here. So enumerate sorted nums. Now let me submit it to check if it works. There's something wrong with this one. K equal to 0 and it should be 2. Now let me check why it is wrong. Normally if this way minus this one is bigger than k, so this k is 0. I didn't expect I make a mistake. Let me just put it like this way. I'm gonna sort the nums first. So nums dot sort. I'm gonna sort it first and then put the infinity. And here, I think it's the same. Now let me submit it. So this one works. So basically I think it should be the same. Because if I sorted the nums, even if I didn't sort the nums, I have to sort the nums first because I need to find the first number. If I didn't sort it from the beginning, this number may not be 1, it may be some random numbers, so this is why it is wrong. So I have to sort the numbers first before I use the enumeration. Because I think it has no influence. I don't need to sort it at first. I have to because nums L must be the minimum number. I think it should be the same. I don't know why. But for the normal way, we should sort the numbers first. We should sort it first and to put the infinity here, and then we're gonna check it. But if we don't sort it, we can put it here like this way, and here should be inside a sorted of nums. I think it should be the same. And this nums L from the beginning would be 0. But it is wrong. Let me just check it why it is wrong. So as you can see here, we have a nums like that, but from here the nums gonna be different. As we can see, from here the nums is like this. But for our way in enumerate sorted nums, we can say this nums is still the same. Yeah. So this means we cannot use this nums. We have to use the sorted nums. So this is why it makes the problem. It has the wrong result. Actually, this nums is not sorted. Yeah, we should understand that. We have to sort the nums first. Otherwise, we have to use something like this. Nums should equal to sorted nums. But that is too much confusing. Yeah, as you can see, it is right. So this means we cannot use the enumerate inside the sorted nums, because the sorted nums is sorted, but nums is not sorted. So we have to sort the nums first. So let's try to solve it in this way. So we're gonna sort the nums first, and then we're gonna plus infinity, and then we're gonna enumerate the nums to check the result. Yeah, now it is working. Thank you for watching. See you next time.